Assalamualaikum and good day to my supervisor, Dr. Engineering Al-Hassan Salami Tijani, and my panels, Associate Professor Dr. Ramdan bin Zailani and Dr. Muhammad Shahar bin Muhammad Shawal. My name is Nur Hanani Binti Ruzli, and today I would like to present my final year project 1 proposal. Before I start, I would like to inform the panels that there was a slight change in my title. My current final year project 1 title is Numerical Analysis of Natural Convection Heat Transfer of Solid Vertical Cylinder Heatsink with Perforated Branch Fins. Firstly, I will explain on the project summary. Nowadays, many industrial systems are utilizing the modern technologies which increases the consumption of time span and processing rate, which also increases the probability of system failure. Thus, this is where the usage of heatsink is introduced. Heatsink is a device that transfers heat energy from high temperature equipment to a low temperature fluid medium, or in simpler words, it absorbs heat generated by electronic component as passive heat exchanger. The fluid medium is usually air, but it can also be water, refrigerant, or oil. But for my final year project 1, I have decided to use air as the working fluid. The main objective of this project is to determine and compare the thermal performance of existing model with the new heatsink model design. And there are 4 different solid vertical cylinder heatsink designs that has been proposed and evaluated under natural convection heat transfer. And the methods used to accomplish this project is by CATIA V5 software and also ANSYS Fluent software, where CATIA V5 software was used to design the heatsink, and ANSYS Fluent software will be used to analyze the thermal behavior of the heatsink. So these are the 4 different solid vertical cylinder heatsink design that has been proposed. The first one is solid vertical cylinder with 20% notch perforated branch fin heatsink. Second one is solid vertical cylinder with 30% notch perforated branch fin heatsink. And the third one is a solid vertical cylinder with forward splitter and perforated branch fin heatsink. And lastly is solid vertical cylinder with backward splitter and perforated branch fin heatsink. So these are the geometrical model of the proposed heatsink, whereby it shows the 20% notch perforated branch fin and also the 30% notch perforated branch fin. And this is the geometrical model of forward splitter and perforated branch fin, and also the backward splitter and perforated branch fin heatsink. Next, I will briefly discuss on the introduction of this project. The immediate leap of growth in electronic industry has driven researchers to study on the efficient techniques to avoid system failures and overheating problems. Thus, ideal design of heatsink is essential to use in order to cater to the evolving performance of the electronics. And extended surface such as fins are widely used to increase the heat dissipation rate in electronic component by either natural convection, forced convection, or combination of both. A study of the performance of tree-like fins with various bifurcation angle, scale, material, and width to thickness ratio and heat flux was carried out, and it was found that the proposed design has the highest effectiveness and has lower base temperature than the regular fin. And moving on to the perforated fins, it was also found that the perforations of the surface of the fin can improve the heat transfer in cost-effective way due to the perforations reduce the material of the heatsink. And plus, the perforated fins are also lighter in weight than the solid fins. And apart from perforation, notch fins are also used to increase the heat dissipation rate in electronic component. Kiran Belda investigated on the on the effect of rectangular notch fin on cylindrical heatsink, and result shows that 10% notch and 20% notch fins produce higher convective heat transfer, which leads to increase in the heat transfer of the cylindrical heatsink. However, to my best knowledge, there is no experimental study in the open literature regarding the effect of solid vertical cylinder perforation heatsink with notch branch fin and forward and backward splitters. And therefore, in this present study, the proposed design are going to be studied under natural convection. Next is the problem statement of this project. Many industrial systems are utilizing the modern technologies which increases the consumption of time span and processing rate. With increase in consumption, the heat transfer in critical cooling application must be increased as well to avoid unbalanced power distribution in the system, which will result in system failures or overheating problems. And the existing heat sinks that are being used can be enhanced by changing the properties and characteristics of current heat sink, such as material, area, shape, and also addition of splitter. This research focused primarily on these objectives. First is to analyze the natural convection thermal characteristic of solid vertical cylinder perforation heatsink with notch branch fins and forward and backward splitters. Second is to compare the thermal performance of a newly designed novel heatsink with conventional design. And the thirdly and lastly is to validate the simulation results with experimental data of previous research under natural convection. Now I will explain on the scope and limitation of this project. The scope is to seek and analyze heat transfer characteristic of solid vertical cylinder perforation heatsink with notch branch fins and forward and backward splitters, while the limitation of this project is all researches are strictly from previous study, and therefore the knowledge gain is not as compact as conducting the experiment at thermodynamic laboratory in UiTM Shah Alam. These are some of the literature reviews taken from previous journals and articles. For first one is Karlapalem studied on the design of perforated branch fins in lamina natural convection stated that the branching fins has more effectiveness and higher efficiency compared to the rectangular fins of equal mass and equal base area in all orientation. Tucker studied on experimental investigation of orientation and geometry effect on additive manufactured aluminum LED heatsink under natural convection and stated that the aluminum alloy is used in heatsink due to its lightweight and has high thermal conductivity. Next is Karakami and Kamkari studied that about the effect of perforated fins on thermal performance enhancement of vertical heatsink, and this study uses circular perforation of the plate fins. After carrying out the experimental investigation, the result shows that the time average Nusselt number for the perforated heatsink is 30% higher than the conventional design. And fourth one is Kiran Belda investigated on the effect of rectangular notch fins on cylindrical heatsink, and the result shows that 10% notch and 20% notch fins produce higher convective heat transfer, which leads to increase in heat transfer of the cylindrical heatsink. And lastly, Hossein highlighted that arch and forward arrangement splitter has the highest heat transfer coefficient. So this is the mathematical modeling. These are the general equations that can be applied in these present studies, which are thermal resistant based on the fin model, convective heat transfer rate, average heat transfer coefficient, mean film temperature, coefficient of volume expansion, Grashof number, Rayleigh number, and also Nusselt number. This slide shows the calculation of procedures of Nusselt number equation. And the first step is to find the total surface area of the heatsink and then substitute the total surface area into the heat transfer coefficient equation. And lastly, substituting the heat transfer coefficient equation into the Nusselt number equation. And this procedures of Nusselt number equation is applied to all proposed design as well. Now we move on to the industrial application of heatsink. Solid vertical heatsink are widely used in LED industry. Therefore, the new design heatsink is subjected to application of bay light LED, where it can help enhance the heat dissipation of the LED light. So this is the exploded view of bay light LED and its component in the bay light LED. Next, I will briefly explain on the methodology of this project. There are 4 stages of phase. The first phase is a research phase. This is where we gather data and information. This process can be carried out by studying and referring to previous studies, journals, articles, and also from textbook or lecture notes from previous subject. This process is very crucial because the information and knowledge gained helps to have a better understanding regarding the parameters and derive equation of the project. Next is generate design idea. According to several studies, it emphasizes that branch fins can be used in cooling system in different thermal system compared to plate fins. And furthermore, decrease in fin area will increase the heat transfer coefficient. A study from Hosseini stated that the splitter usage in heatsink is an effective method to enhance the thermal management in electronics. The second phase, which is the design phase, comprises of geometrical modeling and model equation for physical properties. This phase will be shown in the next slide. The third phase is the simulation phase, where mesh geometry will be created and run for simulation using ANSYS Fluent software. And lastly, the last phase is the result and discussion phase, where simulation results will be compared with the experimental result from the previous researchers related to the project entitled to achieve the objective of this present study. And this is the physical properties adopted in this project, which are density, viscosity, thermal conductivity, and specific heat capacity for both air and also aluminum alloy. So this is the geometrical model of a solid vertical cylinder with 20% notch perforated branch fin heatsink. This is the geometrical model of 30% notch perforated branch fin heatsink. This is the geometrical model of a solid vertical cylinder with forward splitter. And this is the geometrical of the forward splitter itself. This is the geometrical model of solid vertical cylinder with backward splitter and perforated branch fin heatsink. And this slide shows the geometrical model of the backward splitter itself. Now let's move on to the expected result of this project. This result is taken from previous journals by Kiran Belda, where he studied 3 different sizes of notch, which are 10%, 20%, and 30%. The following CFD analysis of cylindrical heatsink shows the distribution of airflow analysis, where 10% and 20% notch size has the highest air temperature noted in the range of 307.76 Kelvin to 319.51 Kelvin. This previous study also stated that the value of pressure drop increased for 20% notch area compensated, where it is notably remarked that the increase in pressure drop will enhance the heat transfer. This result is taken from previous journals by Hossein, which studied the effect of splitter shape on heatsink, and the result shows denote better overall performance of the forward arrangement than backward arrangement. Therefore, based on the result from the previous studies, it is expected that this present study will have a positive outcome. And finally, we have come to the last part of this presentation, which is the project planning for this final year project 1. The yellow mark indicates the planned dates, while the blue mark indicates the actual project date. While this slide shows the project planning for final year project 2. And that's all for my final year project 1 proposal presentation. Thank you for listening and have a good day.